Hello and welcome to my next tutorial about PrePoMax. This time I will show you how to analyze a beam on elastic foundation. Let's create a model first, and we will go back to a three-dimensional model space, and I can confirm this and import the geometry. In this case the geometry will be very simple because this is just a rectangular beam, but what is complex is the behavior of the structure due to elastic foundation. You will see that analytical calculations will be quite complex. Let's mesh the model first. I will specify maximum element size of 20 millimeters, and I will mesh the model now. Mesh is created, so we can proceed to the setup of the analysis. Let's define the material first, and this will be standard material, steel, like we use in most of the tutorials, and I will specify the Young's modulus and Poisson's ratio for this material. And now I will define section. This will be solid section assigned to the beam. Now before I will proceed to the step definition, I will also specify constraint, and this will be surface spring, because those are the two quite new constraints, point spring and surface spring, and they both use the spring keyword in CalculiX, but the surface spring is defined for surfaces and point spring is defined for vertices. So let's choose the surface spring constraint, and I will apply this to the bottom face of the beam. And let's check what value we should use. This is the value that we assume for the analytical calculation. And here is the input for PrePoMax, because PrePoMax uses different units. I had to multiply this by the area defined here, and this gave me the value of the foundation stiffness. So let's define this, and this will be in y direction, so I will specify this directly here. And now I can confirm this. You can see that the spring symbol appeared. And now let's define the step, and this will be regular static step, and I will specify boundary conditions and loads. For boundary conditions we assume that the beam is simply supported, so I will fix all the translational directions here, and then I will pick the opposite edge, and in this case I will fix the translational directions in 1 and 2nd, and I will leave this one unconstrained. Now let's define the pressure, and the pressure will of course act on the top face of the beam, and the value is also provided in this sheet. You can see that the pressure we'll use for this analysis is in this case calculated from the force, then it's converted to line load, and then finally to pressure that we want to apply in PrePoMax. So let's specify this value in PrePoMax. Let's define this, and this will be pretty much the whole setup of the analysis. So the pressure is specified. I can submit the analysis now. As you can see, the results are already available, so let's check them. And let's of course compare them with the analytical solution, like we always do. I will choose the von Mises stress first, or I can use the stress proper stress component. And let's go down to the results in this sheet, but I will also scroll slowly through the whole sheet because you may want to recreate this. And you can see that the formulas are very complex here. There are multiple constants that have to be defined, and then they're used for calculation. In this case the beam is assumed to be simply supported, and the equations that I used in this case are from Rourke's formulas for stress and strain, so you can find them there. Let's check the values that we expect. When it comes to the stresses, we expect them to be around 2 megapascals. So let's check the value that we have in the analysis. You can see that if we exclude the stresses at the regions with boundary conditions and probe the areas in the middle of the beam, you will see that the values are very close to the analytical solution. So this is what we expect in this case. And now let's check the displacements. So I will switch to displacement in y direction, and let's check the sheet. You can see that this is the value of the displacement we expect in this case, and let's compare this with analytical solution. Again, I will query the results in the middle of the beam, and you can see that there is a small difference, but the results are in very good agreement. That's it for this PrePoMax tutorial. Thank you very much for your attention. As always, feel free to ask any questions and suggest topics for future tutorials in the comments. Have a nice day and see you in the next video.